Hello everyone, and welcome to this video tutorial. My name is Sushan. I'm an engineer on the Azure Front Door team. In this video today, we'll talk about anomaly detection, what it is, what tools are available in Azure to detect anomalies, and how can we leverage these tools to protect our Azure Front Door endpoints against Layer 7 attacks by dynamically updating the linked WAF policies in near real time. Okay, before we dive in, let's take a quick peek at the overall structure of today's video. First, we'll talk about what is anomaly detection and what do we mean by dynamic WAF policy updates. Then we'll go on to defining the problem statement. In this section, we'll describe exactly what we're building today. Once we know what we're building today, we'll take a look at an architecture diagram showcasing the various Azure services involved in building our solution and how they interact with each other. And finally, we'll see it all in action. We'll create all the resources necessary to set things up. We'll simulate a traffic spike and we'll see that spike getting mitigated in near real time. Okay, so what is anomaly detection? Anomaly detection is a technique to detect outliers. It is used to identify data points that deviate from a dataset's normal behavior. For example, here is a chart for the incoming requests per second for an Azure Front Door endpoint. You'll notice that there are 3 spikes in RPS which stand out from the rest of the data points. Anomaly detection tools can help us identify these spikes. Not only can they help us identify these spikes, they can also alert us when these happen. Now, what we do with those alerts, how we act on them, is something that we'll see in a minute. Okay, before we go any further, let's quickly go over a couple of tools in Azure that can help us detect anomalies and alert on them when they do happen. The first tool we're going to talk about is Azure Monitor. A lot of you might already be familiar with this service. It is essentially an Azure service which collects telemetry from all other Azure services and allows customers to analyze their telemetry data and create alerts on it. The alerts it offers comes in 2 flavors, static threshold and dynamic threshold. So static threshold is essentially your vanilla alerts which require you to specify what threshold should be exceeded for the alert to fire. An example would be when the requests per second exceed 100, fire an alert. Now, the question is, what happens if the value of the metric depends on the time of the day or the day of the week? Let's say there is an enterprise service for which the average RPS is 100 during the weekdays, but it drops down to 10 or even 1 during the weekends. Now, if this service was to be attacked on a weekend and the attack spikes the RPS up to 50, the static threshold alert that we defined earlier would not fire, and it would not help with the attack. Now, we can certainly alleviate this by defining 2 static threshold rules, one for the weekdays and the second for the weekends. And the one for the weekends will fire when the average RPS is over 10, the one on the weekends will fire when the average RPS is over 100. But the question is, what if the RPS is different every hour? What if it's different during the day, different during the night, different on Monday, different on Tuesday? How many static threshold alerts are we going to create? This is where dynamic threshold alerts come to rescue. Dynamic threshold alerts automatically detect this threshold by applying machine learning techniques on the historical values of the metric. To help illustrate this better, let's take our attention to the chart on the screen. The blue highlighted area or band that you see represents the range of expected values for the metric at a given point in time. The dynamic threshold algorithm that this alert is backed by creates this band based on the historical values of the metric on a given hour of the day, a given day of the week, or a given month of the year. If the value of the metric was to go out of this band, whether above or below, it would be considered an anomaly and an alert would be fired. So essentially what it would allow us to do is to define a single alert for all days of the week in all hours of the day, and that alert would fire whenever there is a deviation from the norm. An important thing to mention here is that when these alerts do fire, they can be sent to multiple destinations in Azure, like the logic apps, the webhook, or Azure functions. So something meaningful can be done as a response to these alerts. Next, let's look at a more advanced tool available in Azure for detecting anomalies. It's called Azure Metrics Advisor. Azure Metrics Advisor is a service that provides advanced AI-based metric analysis. It features multiple anomaly detection algorithms, anomaly grouping, and rich incident management capabilities. And of course, it also lets the user configure alerting on these anomalies. Similar to Azure Monitor, when the alert does come in, it can be sent to logic apps, webhooks, Azure functions, etc. to take a meaningful response. Now, for the purposes of this tutorial, we'll stick to the simpler Azure Monitor dynamic threshold-based alerts, but feel free to check out Azure Metrics Advisor for additional advanced anomaly detection capabilities. Okay, so now that we know what anomaly detection is, what tools we have at our disposal to detect and alert on these anomalies, we have everything we need to detect a layer 7 traffic spike as a result of an attack. Now, once we detect this spike, how do we mitigate it? What do we do in response to the alert from one of these tools? This is what we'll discuss next. One option to slow down the traffic in response to the alert is to deploy WAF rate limit rules for the front door endpoint. These rules will effectively slow down the incoming traffic to a threshold specified in the rate limit rule. Doing this automatically is precisely what we mean by dynamically updating WAF policies. So our WAF policy might start off with no custom rules, which is the policy that you see on the left. And then as the alert comes in, we want to automatically add some rate limit rules to it, which is what you see on the right. Okay, so now that we know how to get alerted when an attack is happening and what do we want to do in response to that alert, we're now ready to define the problem statement for today's tutorial. Okay, we're going to define the problem statement in 3 steps. The first step is setting up the alert. This is going to be done using Azure Monitor's dynamic threshold. It's going to be on the request count metric of an Azure Front Door endpoint, and it's going to be on a per country basis. The per country part is something that we'll see a little later, but what this essentially means is that the alerts are going to be separate for each country. So if there is a request count anomaly in Australia, it's going to fire one alert. And if there is a request count anomaly in Canada, there's going to be a separate alert that's going to be fired. Next, this alert is going to trigger an Azure function. This Azure function is going to be used to extract meaningful information from the alert, like the country in which the alert was fired, the baseline request count values at the time the alert fired, and it can also connect to log analytics service and extract the IPs which were sending traffic at the time of the alert fired. Then this Azure function is gonna create and deploy some WAF rules. More specifically, it's gonna deploy 2 rules. Now, we're not limited to deploying these 2 rules. These are completely for illustration purposes. But in this case, the first rule that we're going to define is a rate limit rule on the country where the alert was fired. And we're going to set the rate limit threshold to 10x the baseline. Why are we setting it to 10x the baseline? It's not a hard and fast rule. You can set it to 1x, 2x, 100x. It completely depends on your specific scenario. It would depend on factors like how much confidence do you have on the alert, how much origin capacity do you have, and it will also depend on the intensity of the attack. So again, it's just to demonstrate that the baseline can be used to come up with that rate limit threshold. The next rule that we're going to define is we're going to extract the top 10 IPs that send traffic from that country during the alert or the attack window, and we're going to rate limit each of those IPs to 1/10 the baseline. Again, the idea here is to demonstrate that how to extract IP addresses from the request traffic during the attack window and how to leverage that information to craft a tailor-made response which targets specific IP addresses. Okay, now that we have a clear understanding of what are we going to build today, let's just see the big picture view of how everything fits together. Let's assume this user is an attacker and they're sending a barrage of requests to an Azure Front Door endpoint. Every time a request comes to an Azure Front Door endpoint, it's going to emit metrics to Azure Monitor. And if configured or if opted in, it's also going to send or stream request logs to a log analytics workspace. Now let's assume that we have our dynamic threshold alert set up. After this attacker sends enough requests, an anomaly is going to be detected via that alert, and it's going to trigger this Azure function here. This Azure function is going to extract some information from this alert, and then it's also going to query the log analytics workspace to get the request logs from which it's going to extract the IPs that sent the most amount of traffic. And in this case, it's going to be the IP of this attacker. Once it has all of this information, it's going to create the two WAF rules that we discussed in the previous slide, and it's going to deploy this WAF policy globally. Now, once the WAF policy takes effect, this attacker is going to be limited in the number of requests it can now send, thereby mitigating the attack. So this is basically how an attack or a spike in traffic is going to be mitigated, and all of this is going to happen in the context of a particular country or geography. An additional capability offered by Azure Monitor is that it'll also inform you when the anomaly has been resolved. So when this attacker is no longer able to send enough traffic to create an anomaly, eventually the traffic is going to go back to normal, and Azure Monitor is going to send another update in which it will tell this Azure function that the anomaly has now been resolved. So now we can code up this Azure function in a manner where it can now remove those two rate limit rules and then deploy the WAF policy. So there are no longer any restrictions in terms of any traffic getting rate limited in that country. With this, it's time to see things in action. We're going to do it in two steps. First, we're going to set everything up. As part of the setup, we're going to create a WAF policy first. Then we're going to create an Azure Front Door endpoint, and we're going to link the WAF policy that we created in step 1 to this Azure Front Door endpoint. Next, we're going to define a dynamic threshold alert on the AFT endpoint. It's going to be done on the request count metric. And finally, we're going to create an Azure function, which is going to do everything we've talked about so far. Since it's such an important part of this tutorial, we're going to walk through the code and showcase how this Azure function extracts information from the alert, like the country where the alert was triggered, how it queries request logs from log analytics, and how does it use Azure SDK to add custom rules or rate limit rules to the WAF policy and how it deploys that WAF policy globally. Next, we're gonna demo things. To demo things, we need to simulate an attack. We're gonna do this by creating an Azure function, and we're gonna deploy it to multiple regions to simulate an attack happening simultaneously in multiple countries. Next, we're gonna showcase that the attack indeed started. We're gonna do this by inspecting the request count metrics for the front door endpoint and see a spike in the count. Once we see a spike in the count, we'll wait for a few minutes for the alert to fire. It should typically fire within like 5 to 10 minutes of the spike starting. Once the alert is fired, we'll showcase that the WAF rate limit rules got auto-created in the portal. Once we see those getting created, we'll then wait for the attack to be auto-mitigated. We'll do this by inspecting the metrics again, and this time we'll see an increase in the requests getting rate limited. We'll see a decrease in the number of requests which are served successfully, and then finally we'll see that the alert got auto-resolved. When the alert gets resolved, the Azure function will get called again, and this time the Azure function will remove the rate limit rules from the WAF policy and then deploy the WAF policy, and everything should just go back to normal. Okay, let's get started. The first step is to create a WAF policy. To do that, I have an Azure Window Portal tab open here. I'm going to type WAF in the search box, select Web Application Firewall Policies, and then hit Create button. In the policy for, we're going to choose Global WAF. For the front door SKU, you could choose either Premium or Standard. For this, I'm going to choose Standard. Pick your subscription resource group, pick a policy name, let the policy state stay enabled, change the policy mode to prevention, and then you can leave everything else as blank, and then you can hit review and create to complete the creation of WAF policy. I already have one created. I don't have any custom rules. I did not add any managed rules or fiddle with the policy settings at all. So it's pretty much a blank slate of a WAF policy. Okay, the next step is to create an Azure Front Door endpoint. To do this, we're going to type front doors in the search box, select front door standard/premium preview. Hit create. Choose custom create. Hit continue to create a front door. Select your subscription resource group, a name of a front door, and select a front door tier. This tier is important because this needs to match the SKU of the WAF policy that you created in step 1. Now, if you are serious about protecting your front door endpoint against malicious web-based attacks, it's recommended to choose a premium WAF policy because premium WAF policy offers managed rules, which is a prepackaged set of rules to protect against several well-known web-based attacks, and it also offers bot protection. Standard WAF policy, on the other hand, only allows you to create custom rules. While for the purposes of this tutorials, we're only creating standard custom rules, so standard WAF policy might be okay, but if you're serious about protecting your endpoint, we'd recommend choosing premium tier. We don't need secrets for the endpoints. Hit add an endpoint, give the endpoint a name, hit add. Let's add some origin groups to our endpoint, give this a name. We need to add at least one origin to this origin group. Again, give it a name. Pick whatever is the appropriate origin type. I'll choose custom just as a sample input. Put in your host name, select the right host name here. I'm just choosing bing.com as a sample, and then hit add. Next, let's create a route and give it a name. Select the domains and then select the origin group. And then if you want to enable caching, it's up to you. We don't need it for this tutorial. Hit add. And finally, we're going to select the WAF policy. From the drop down here, select the WAF policy that you created in step 1. I created Azure Front Door WAF policy. Select the domains that you want to attach this WAF policy to. Now, please note that if you want to add more custom domains to this front door endpoint, you can absolutely do that and then come back to this screen and edit this endpoint and attach those additional custom domains to this WAF policy. Go ahead and hit add, and this is pretty much it. Now you can go ahead and create this front door profile. I've already created one and it looks like this. I have an endpoint here with a custom domain added to it. I have a origin group. I created a route and I attached the WAF policy that I created in step 1 to this endpoint. So this completes the creation of Azure Front Door endpoint. Okay, the third step of the setup process is to create an alert rule, more specifically a dynamic threshold based alert rule. To do that, we're gonna hit alerts button here. We're gonna hit create alert rule. And then for the signal type, we're gonna select metrics. And from the list of metrics, we're gonna pick request count metric. And then you're gonna see a little chart here which will show you the request count over the past 6 hours. You can change it to over the last week and you'll see what requests you have been getting over the past week. Next, split by dimensions. Here we want to split it by client country because we want to get an alert per country. So we're going to select all current and future values. For the alert logic, we want a dynamic threshold alert. We only want to get alerted when the deviation is greater than the normal, not below the normal, or not greater than or below. We never want to get alerted when it's below. We don't care. For the aggregation type, you could pick average. For the sensitivity, this is an important one. So sensitivity is the extent of deviation required to trigger an alert. So let's take an example. So if the normal request count at a particular time is 100 and all of a sudden it becomes 101, then the deviation is 1. And maybe so the deviation is not very high. So if you pick a low threshold sensitivity, the alert might not trigger. So if you want the alert to get triggered even with a very minor deviation from the norm, pick high threshold sensitivity. If you want to only trigger an alert when the sensitivity is when the deviation from the normal is significant, then pick a low sensitivity. We're gonna stay in the middle and pick medium sensitivity for this tutorial. And then for the granularity, we want the lowest granularity frequency of evaluation. We want the lowest possible because we want to detect the alert as quickly as possible. Unfortunately, right now, Azure Monitor, this is the lowest granularity that it allows on dynamic threshold based alerts. If you go and look at static threshold, it allows a granularity of 1 minute. So we would ideally have liked the granularity of or the frequency of evaluation of 1 minute, but we don't have it available for dynamic threshold rules as of now. We may or may not get it in the future. Not sure about that. For the number of violations to trigger. Let's just pick one violation in the past 5 minutes, which is our aggregation granularity period. And then, so even if there is one violation in the past 5 minutes, it's gonna trigger alert. That's it. Hit done, and then the next section is actions. This is the section where we're gonna hook up an Azure function to be triggered when this alert rule fires. Since we do not have that Azure function right now, we're going to have to come back to it when we do create and publish that Azure function. So we're going to do that in the next step. Details, just pick out a name, select your subscription resource group, the general stuff, give it a description. We want to enable it. We do want to automatically resolve the alerts. That's it. Hit review and create, and then if everything looks okay, hit create. I, per usual, already have a alert rule created here, and calling it request count anomaly. It's exactly what we just discussed. When the total request count is greater than the dynamic threshold, then it's gonna get triggered with a medium sensitivity. And then I already have an action group defined here, which has a Azure function linked to it, but we'll see all of this in the next step. So as far as creating the rule is concerned, this is pretty much it. Next, let's talk about the fun part, which is the Azure creating, defining the Azure function and walking through the code. Okay, so Azure function. Since this is going to be a little bit involved, let's break it down into steps to make it easier to understand. The first step is going to be to create a Visual Studio project for this Azure function. Next, we're going to write some code to parse the Azure Monitor Alert schema. This is so that the function can extract information from the alert. Then we're going to do a code walkthrough. First, we're going to look at how do we extract logs from the log analytics workspace, and these are your Azure Front Door request logs. You do have to be opted in to get these logs into log analytics, and that's something we can talk about in a little bit, how to do that. Next, we're gonna see how do we use an Azure SDK to get the WAF policy in the Azure function. Once we have the WAF policy, we'll see how do we add WAF rules to that WAF policy, and this could be add or remove based on whether the alert is fired or the alert is resolved. So we're going to see how to do that, and then finally we're going to deploy this function to Azure. Okay, let's see how to do the first step, which is to create a Visual Studio project. So I have a Visual Studio window open here. I'm going to hit File, New Project. I'm going to select Azure Functions, give it a name, hit Create. It's going to ask for if you want an HTTP trigger or if you want something else as a trigger. Let's stick to HTTP trigger for now, and you can pick your storage accounts and authorization level here. Go ahead and hit create. It's going to create a sample project with a sample function. Next, we're going to look at how do we change this to process the Azure Monitor alert. Okay, to be able to parse the Azure Monitor alert schema, we first need that schema. Now, how I did this was I created an Azure function. I hooked it up to the Azure Monitor alert, and I let that alert fire. When that alert fired and triggered the Azure function, I just captured what was sent in the request body. I pretty much deserialized the JSON that got sent, and this is what that JSON looked like. So what I did next was I am gonna select this JSON, and then I'm gonna say, hey, add a new class to this project. So let's do add new item. We can call it anything. Let's call it the alert schema class. right? And then I simply did a paste special, which has an option to paste that JSON as classes. That's it. Once I did this, I was able to parse the schema, and we'll see how that looks like in a minute. Okay, let's go over to the function that I have pre-created. So this is my function. It's called process AFD alerts. The first step, as we discussed here, is to parse the incoming alert message. To do that, I just read this request body, and once I read the request body, I put it into a JSON convert deserialize object, and what I want to deserialize it to is this alert body, and this alert body is what I got by pasting that JSON that we just saw as classes. So once I do this, I have the alert body, uh, and then using this alert body, I'm able to extract information about this alert. So more specifically, I want to know what country the alert was fired in and what was the baseline threshold, or what was the expected value of the request count at the time the alert was fired. So I extract these two things from my alert, and then I create this alert info object. Next, we want to see whether the alert fired or whether it got resolved. Because if it got fired, we want to add rules to the WAF policy, and if it got resolved, we are going to remove the rules from the WAF policy. And again, this is purely for illustration purposes. Your use case might need you to do something completely different. Next, let's look at what do we do when the alert is fired. The first step is to capture the baseline threshold. This is the expected value of the request count metric when the alert was fired, and this information is part of the alert that we deserialized into this alert body. Next step is going to be to extract the logs. So the reason we want to extract the logs from this alert is because logs is where the IP addresses of who has sent how many requests in the past X minutes is stored. And because we want to create a rate limit rule targeting the top 10 IPs sending the most traffic, we need to get those IPs first. This is where getting the logs comes into picture. Before we look at how can we get logs programmatically, let's first take a quick peek at how do we set up, how do we opt into getting these logs, and how do we get logs from the Azure portal. To do that, we go back to our Azure Front Door endpoint. So this is my Azure Front Door endpoint that we saw before. I'm going to go to diagnostic settings, and here you can add a new diagnostic setting where you can give it a name, and you can say that you want either all the logs or front door access log, health probe log, web application firewall log, and you can select where do you want to send them to. For this tutorial, you're going to want to send them to a log analytics workspace. So you select your subscription, you select your log analytics workspace, and you hit save, and that's it. So I already have all of this set up to go to my log analytics workspace. So let's go to that workspace to see how can we query the top IPs sending traffic. To do that, we're gonna go to our log workspace. Notice there is a workspace ID here. We're gonna need this ID when we programmatically try to get logs from this workspace. But for now, we can click on logs, cross this out. So this is my query to get the top 10 IPs sending traffic in a specific country in the past 30 days. Obviously, when we're programmatically getting this from in the Azure function, we're not going to want to get the data for 30 days. We'll probably want to get the data for like 10 minutes or 5 minutes. So all this query is doing is it's getting for the past 30 days for this resource ID, which is our front door. The client country is something that's going to be included in the alert that triggers the Azure function. All this query is saying is that summarize the request count by client IPs, where the request count is greater than one. That is, the client IP should have at least sent one request, then order them by the request count. So the IP sending the most amount of requests are going to be at the top, and then take the top 10. So when we run this query, the results are going to look something like this. So in this case, this IPv6 address sent 2101 requests in the past 30 days, and then this IP which is slightly different. For a second I thought it's exactly the same, but this is F993 and this is F969. It sent 454 requests in the past 30 days. So I did not send any requests recently. So if I change this to, let's say, 10 minutes, it's probably not going to return anything. But if an attack happened and the alert was fired and the Azure function was triggered, it probably means that there was quite a bit of traffic or quite a bit of unexpected traffic in the past 10 minutes, and we'll for sure get some entries there. Okay, now let's try to go back to the code and see how do we do this programmatically. We hit logs. So you need a few things. You need the workspace ID. This is what we just discussed a minute ago, where you want to capture the OMS workspace ID where your logs are being sent to. And then you need some credentials to access the logs. So what I did was I created a AAD app, and I created a secret in that AAD app, and I gave that AAD app permissions to query this workspace. And then, so once you do all of that, you can create a credential with that information, and then the tenant ID is your Azure tenant ID. Once you have the credentials, you can create a logs query client using that credential. And again, this is in the Azure Monitor query nugget package. So you're going to have to add azure.identity and azure.monitor.query nugget packages to this project to get this working. Once you have the logs client set up, you want to define your query, and this is exactly the same query that we just saw earlier. All I've done is dynamically injecting the front door resource ID and the country, because this is the information that we dynamically get from the alert. And then I am trying to get all the IPs which have sent requests more than the baseline threshold, which is expected at the time the alert fired. So pretty much the same deal that we just saw. All we're going to do is use this logs client that we created to query the workspace, and we're going to get a response. Next, we'll look at what this response might look like. Now, before we can capture the response for the logs, we need to define the schema in which the response can be deserialized. So if we go back to our query that we did in the OMS workspace, this is the response. So the response has two columns in it: the client IP underscore s, which is the IP address, and then request count signifies how many requests that IP address made. So I went ahead and defined a new class called row with those two properties. So when we do the query, the response is going to be deserialized into multiple objects of rows, and then that's what we're going to use to extract the IP addresses out of. Okay, now that we know how to get the logs, let's step back. The next step, so before I mention the next steps, if there is no logs, which means it's an unexpected situation, there should be logs if an alert got fired. So if there is no logs, nobody sent any requests, and there is nothing we want to do, so we're going to just simply return. And again, I'll figure out a way to share the source code along with this video. Not sure how I'm going to do that, but I'll figure out a way to do that. So the next step is to now update the linked WAF policy. To do that, we first need to get that WAF policy. To get the WAF policy, we first need to set up the front door client. So this is the front door management client, and this is part of the Microsoft.Azure.Management.Front Door Nugget package. And then we also need the Azure Management Resource Manager Fluent package. So you're going to have to add these two packages to your project. Once you do that, you need to give that same AAD app permissions to create and update, and basically you probably need to give it a contributor permission on the front door and WAF resources, so it can get the WAF policies, update the WAF policies, etc. Once you do that, you can use that AD client ID and then the secret that you created here, and then put your tenant ID, and if you're in the global cloud, use that global cloud. Once you do that, you have your front door client set up the subscription ID to where the WAF policy exists. Once you do that, the next step is to get the WAF policies. It's simply a call on the front door client. It has a list of all the policies, and you can do a get on by passing in the resource group where the WAF policy exists and the WAF policy name. And then if we can't find the WAF policy, we're going to throw an exception, but we can ignore all of this for the purposes of this discussion. So now that we have the WAF policy, we are gonna add rules to that WAF policy. Let's see how do we do that next. Okay, let's look at how do we add WAF rules to this policy. Let's step into this method here. As previously discussed, we're gonna add two rate limit rules. The first one is gonna rate limit on the country, and we already have knowledge of which country the alert was triggered in, and we extracted that information from the alert into this alert info object, which captured the country and the baseline threshold. So with that information, we can create the first rule, which is simply going to be a new custom rule of type rate limit, and we'll have to figure out a priority for this rule, and the match condition is simply going to be when the IP address of the sender matches this country code. Simply block the request. So you only want to allow a handful of requests in the rate limit duration, and in this case we decided to pick 5 as the rate limit duration. You could have picked something else, it's just for illustration purposes. When you create the rule, add that rule to the WAF policies custom rules, and then set it to enabled. And then the next important step is what should be the rate limit threshold, like how many requests do you want to allow in that 5-minute interval. So as we discussed previously when we were defining the problem statement, we are gonna try to rate limit the entire country to 10x the baseline threshold. So we captured the baseline threshold from the alert. So here we're saying that if 10x the baseline threshold is less than 1000, then use 1000 as the number to rate limit the request. Otherwise, use that 10x that we previously discussed. Again, you can choose to do 100x, 1x, but the important thing to notice is that we're using the expected threshold to come up with the rate limit threshold. Okay, so the next rule we want to look at is the IP rule. We already got the logs, and these logs contain the IP addresses and how many requests they sent. So we're going to use this information to create a rate limit rule targeting these specific IP addresses. So this is again going to be a custom rule, which is of type rate limit. We're going to have to assign it a priority, and we'll talk about priorities in a little bit and how we handle these, especially when multiple rules can get created through multiple alerts firing in different countries. Match condition this time is going to be if the IP address matches the IP address in addresses in our logs. So we're going to use the logs, and we're going to get all of the IP addresses from the log. We're going to put it in this list, and this is the list against which the custom rule is going to be created, or the custom rules match condition is going to be created. As far as the rate limit threshold is concerned, again, we wanted to rate limit it to 1/10 the baseline threshold. So we can do something like if 1/10 of the baseline threshold is less than 100, then use 100. Otherwise, you can use 1/10 of the baseline threshold as the rate limit threshold. And again, we want to enable this rule as well. Next, let's talk about how are we assigning priorities to these rules. And this is an important concept because multiple alerts could trigger or could fire from different countries simultaneously. To illustrate this, let me open a notepad window real quick. So imagine if an alert fired in Australia, and then at the same time or a little bit earlier or later alert fired in, let's say, Canada. So when this alert fires, the Azure function is going to get triggered, and it's going to create first a rate limit rule for Australia and set it to 10 times the baseline. And then it's going to capture the top 10 IPs and rate limit top 10 IPs in Australia to 1/10 of the baseline. Similarly, the Azure function is going to get fired for the Canada alert as well, and it's going to do the same. It's going to try to create these same two alerts for Canada. Now, the interesting thing here is all of these alerts are going to the same WAF policy. But a WAF policy needs to know how to process the alerts, or how to process the rules, that is, in what order to process these rules. So this is where we're going to have to define some logic. And what I did was I hard-coded a priority per country, because it does not really matter to us in what order do these get processed, but we do need to organize them in a way such that there is some ordering, so all of that these can be put into the WAF policy. So what I did for the purposes of this tutorial, and I can show you, is I just assigned a fixed hard-coded priority to each country. So if an alert fires in Australia, the country level rate limit alert is going to get a priority of 5, and then the rate limit alert for the top 10 IP sending the most traffic is going to have a priority of 1005. And again, you can choose any logic to come up with priority, but this is a very simple way of coming with some logic to deterministically determine the priority for these rules. And in addition to the priority, I also have a way of naming these rules. So what I'm doing to name them is I have this format that you prefix the name of the rule with the country code and then followed by like a hard-coded number, which in this case for the uh, rate limit country rule, I'm calling it mitigate DDoS rate limit country rule, and for the IP rule, I'm calling it mitigate DDoS rate limit top request IPs rule. So you can come up with your own scheme of naming them, but it's gonna be important to give them a deterministic name, because what can potentially happen is, and again going back to the notepad scenario, when this alert gets resolved now in Australia, the attack is no longer active. Azure Monitor sends you a notification that the alert is resolved. Now you're going to want to remove these two rules. Now, what if there is 10 rules in the WAF policy? You're gonna need a way to identify which rules to remove from the list of custom rules. So that's where naming them deterministically is gonna be handy. So you know the name, you can pick those rules out of the list and you can remove them from the list and you can save the WAF policy. Okay, so once we do all of this, we have successfully added the rules to the WAF policy. The final step is to use that same front door management client that we created earlier and call the create or update async method. This is essentially going to be a put HTTP call under the hood to the WAF RP resource provider, and you're going to have to specify the resource group, the policy name, and this is the updated WAF policy with 2 extra custom rules in it, and that's it. Once this step is done, the WAF policy is going to get deployed globally in a matter of minutes. Okay, the final step of this part is to deploy this Azure function to Azure. To do that, we're going to right click on the project and hit publish. When you hit publish, you're going to have to create a new publish profile. I already did that, so I already have a publish profile, but let's actually walk through the real experience. So remember the demo project that we created earlier. Let's try to publish that to Azure. So I hit publish. It's going to ask me to create a publish profile. I want to publish to Azure, and then I want it to be an Azure function in Windows. You could choose Linux or any of these options will work. For this tutorial, we're going to stick to Windows, and then you'll pick your resource group, and then you'll pick a function app to deploy it to. So my function app is this one. So once I do this and I click finish, this function is gonna get deployed to Azure. So once you deploy this to Azure and the publishing finishes, it's gonna look something like this. So this is my process AFD alerts function app. I can go to functions, and this is the function that I just deployed. You can click on it. You can play around by doing code plus test here. So you can hit test run and you can kind of like test things out. There is also ways to test this function locally. You can simply hit this button here and put debug points in your code to test things out, and you can use Fiddler to make requests to in this case this is the address that I'm gonna make the requests on to locally debug this Azure function. So you can do all of this and play around with the function. The next step, once we have the function, is to add this function as an action to the Azure Monitor dynamic threshold alert that we created earlier. So we're going to go ahead and look at how to do that. So again, you're gonna go to alerts. You should already have an alert that you created earlier. And in here, you're gonna select this alert, and what you're going to do is you're going to want to add an action group. I already have one, but you might have to create an action group. And while creating the action group, in the actions, pick the Azure function, and then this little window should open up here, and then select your subscription resource group, and then select the function apps that we just published. And once you do that, make sure to enable the common alert schema, because this is basically, if you use the source code that I'm going to publish, this is the schema that I'm using. You can use the older schema as well, but then you're going to have to deserialize that schema and create different uh, classes to parse the alert. So for this tutorial, try to enable the common schema and then press OK. So again, it's gonna look something like this, where you have this action group with an Azure function called process AFT alerts hooked up. So once you do this, every time this alert fires, it's gonna trigger that Azure function. Okay, with this, we are now ready to simulate an attack and see everything in action. So the way we're going to generate the attack today is via an Azure function, and we're going to use this function to generate a little bit of attack traffic to our Azure Front Door endpoint. We'll do this in multiple countries to simulate a DDoS attack, and we'll see how we do that in a second. So let's quickly look at the code for this Azure function. We have a URL, and this is the URL for my Azure Front Door endpoint's custom domain. And all I'm doing is, it's a parallel.for loop, which is going to send about 100,000 requests over a period of time to this endpoint. And since this endpoint does not get much traffic, this should definitely qualify as an anomaly, and it should trigger the alert, which should call into the Azure function, and then finally we should end up with some WAF rules being deployed, and we'll see all of that in action. But first, let's see how do we deploy this Azure function to multiple regions. So you go ahead and click publish, and I have two published profiles. One is for India and one is for France. The way I deployed this to India and France is by picking the South India Azure region and then the Central France Azure region. Let's take a quick look at the deployed Azure function. So this is the function that was deployed to France Central. It has that start attack function here. And then this is the same function deployed to South India region. So when we run, or when we trigger the functions from the respective regions, they're going to launch an attack from India and from France simultaneously. Okay, let's go ahead and start the attack, or start simulating the attack rather. So we're going to hit code plus test. This is the France function. We're going to hit run, and then this is going to start sending requests to our Azure Front Door endpoint from France. Same thing for India. And then we should be able to see this shortly in the metrics for our Azure Front Door. So let's take a peek at for the last 30 minutes. Let's take a look at the request count metric and see what it looks like. So far there has not been any requests in the past 30 minutes. this should change soon as we started these attacks. And then sometimes you'll notice a 503 service unavailable, which is fine because the Azure function is not meant to be a long running thing. It's just something that we decided to use for this tutorial due to simplicity and due to being able to quickly create one. As you can see, some traffic has come in here at 6:09, and this should continue to go up as we send more and more requests from India and France. And actually, let's go and split the metrics by country to see that the traffic is indeed coming from India and France. So as you can see here, 573 requests from France, 211 requests from India. So the attack has started. Now let's quickly look at our front door WAF policy. So far it does not have any custom rules, but this should soon change. So now we're just gonna wait for the dynamic threshold alert to fire and for it to trigger the Azure function, which will add the WAF policy rules here. And once those rules are deployed, we should see these requests getting blocked. So let's actually do this. So let's split by HTTP status. So as you can see, everything right now is a 200 OK. When the WAF rules are deployed and when they start blocking or rate limiting requests from these countries, you should see a whole bunch of 429s. You should actually see the 200s go down and the 429 status code go up. Okay, let's now wait for a few minutes for the alert to fire. We do need to wait for a few minutes because the dynamic threshold rule evaluates every 5 minutes. So it depends on when in the next 5 minutes it's going to get evaluated and to determine when is it going to fire and when everything is going to get kicked off. So let's wait for a bit. Okay, it has been a few minutes now. Let's just check if the alert's fired yet or not. So some alerts did fire, it looks like. So we have 2 warning alerts in the past 30 minutes. So here is an anomaly for India, as expected, and then this one should be for France. So as expected, we have 2 alerts, one for India and one for France. Now let's go back to the WAF policy actually to see if the custom rules got created or not. So we'll go to security tab, and then let's open this in a new window. Actually, no, it's not letting us open it in a new window. Let's check the custom rules here real quick. So as expected, 4 custom rules got created. There is two of them are the rate limit rules for the entire country, and then 2 of them are going to be targeting specific IPs. For example, let's look at this rate limit rule for India. It says if the country is India, then rate limit 2000 every 5 minutes. And then if you look at the IP rule, it'll say that, so these were the IP addresses that it identified sending the most amount of traffic. So it created a rule to rate limit all of these IPs to 100 requests per 5 minutes. And again, all of this is based on the baseline logic that we wrote in the Azure function, and it's all tweakable. You could put whatever limits you want here. Going back to the metrics for a second. So if we look at the metrics, request count, interesting. So as you can see, there is 452K requests in the past like few minutes here. Let's change this to 30 minutes. Let's just keep running the attack for a little bit more. So going back to the metrics, you can see that the request count increased significantly around 6:09 p.m. And let's look at let's add a filter for India actually. So the country is gonna be India. Let's see what's going on. So for India, there is about 102K requests that went in the past few minutes. Let's now apply splitting by HTTP status code. So as you can see, let's change these colors here. So let's make the 200 as green, and let's make the 429s red. Okay, so you can see that at 6:09 or 6:09, 6:10 is when the attack really started, and then this generated an alert at some point, and that alert created those WAF rules, and the WAF rules got deployed globally, and then looks like they started taking effect at about 6:17. So in about 7 minutes, the whole process started automatically mitigating this attack, and then after that you can see a sharp drop in the amount of successful requests and a sharp increase in the requests that were throttled. And after that, there is the requests which successfully go through have been limited to, I think, 1,000 is what we saw, right, in the rate limit rule. So that's what it's going to stay at until those rate limit rules are removed. So we actually do have a provision in the Azure function that we coded where when the alert is resolved, so now if we stop sending any requests, ultimately after a few minutes, this alert will get resolved. So its alert state or monitor condition will change from fired to resolved. And when that condition changes, it's gonna hit our Azure function again. And then this time, let's just quickly take a look at this. This time it's gonna trigger this handle alert resolved workflow where it's gonna update the link WAF policy, and it's gonna say, let's click this. So in handle alert resolved, it's passing a true to the last parameter, which is to delete rules. So when this gets called, it's gonna go into this if statement here, delete rules from the policy, and then it's gonna just delete the 2 rules that it generated when the alert was fired, and then it's gonna save the policy. So ultimately it's gonna end up removing those 2 rules from the WAF policy, and after that we should see the traffic get back to normal. Okay, so it's been a few minutes and we've looked at the auto created WAF rules, we've looked at the attack getting auto mitigated, we've seen that the 429s got sharply increased, we've seen the decrease in the 200 OK requests, and the final step is to see the alert getting auto resolved. Let's see, hopefully the alerts have auto resolved. So let's look at the alerts in the past 30 minutes. Actually, let's look at the alerts in the past 1 hour. Okay, so these are our two alerts that were triggered in the past hour, and both of them are resolved now. So at this point, we should go to the WAF policy and see the custom rules deleted from the policy. Let's go to custom rules, and as you can see, as expected, all of the 4 custom rules have been successfully deleted. So if they have taken effect, uh, the traffic should no longer now be rate limited. So let's launch some more traffic and let's see the metrics and what they say. So as you can see that the traffic pretty much just stopped around this time, and since I started some requests again, we should see it come back again soon, but all of them are going to be 200 OK requests. The one in red, actually, let's change that to blue again, and then the 429 should be the red. So we should start seeing some more 200 OKs. Just sending some more traffic to the endpoint. As you can see, the traffic is kind of picked up as expected, and everything is going to be 200 OK. So right here, it's all 200 OK. So this successfully concludes this demo. The alerts have auto-resolved, the rules have been removed, all the traffic is back to normal. With this, it's time to conclude this tutorial, but before we do that, let's quickly talk about a few key takeaways. First, we noticed that the attack did get auto-mitigated in 7 minutes. Now, this is not a hard number. Sometimes it may get mitigated in less than 7 minutes. Sometimes it might take a few more minutes to get mitigated. It all depends on when that alert fired and then when did the WAF rules got deployed globally. Next, we noticed that the traffic got back to normal when the alert was resolved. This was done by removing the rate limit rules that were put into place automatically. And finally, we want to emphasize the fact that we crafted a tailor-made response in near real time to this attack by using the information from the alert. In this case, we used the country of origin and we used the baseline expected request count from the alert info. And then we also utilized the request logs, more specifically the sender IP addresses, which were sending the most traffic during the attack. We leveraged this information to target specifically those IP addresses. And the source code is going to be available at this GitHub repo, so feel free to check it out. You might have to edit the source and change the name of the WAF policies, add your own resource group subscription, log analytics, the workspace information, and also add information about your own AAD app, which you're going to use to access the various Azure resources. So finally, I want to thank everyone who took the time to watch this tutorial. Hopefully it gave you a glimpse into what is possible and what kind of pipelines or systems can be assembled using the tools available in Azure today. feel free to experiment with the code. You might want to try using Metrics Advisor instead of Azure Monitor for anomaly detection, or you might want to try to set up a static threshold alert rule instead of dynamic threshold. You might want to come up with an entirely new set of rules, for all we know, to protect your endpoint from an attack. Really, imagination is your limit here. Feel free to use more information available in the alert and in the request logs to craft your response. So good luck and have fun building.